All right, welcome back to lecture 16 of the course Agricultural and Biosystems Structures Engineering. The topic is still on other AB structures. We're continuation on the discussion of the following will be done. Okay. Biogas systems, we have also waste management systems, and then shops and non-product storage. That would be uh, taking into consideration warehouse for grains, that is the storage of grains. And then we have farm workshop, machinery shed, fuel and chemical storage, and then the silo, and then some uh, final thoughts on uh, fencing, fencing of structures. The last time was a very lengthy discussion, so we will try to this discussion to be um, a bit condensed compared to last time. Let's start with biogas systems. All right, so this is the standard. This is the prevailing standard for biogas systems. And again, there are different types of biogas. It would depend on the categorization. Okay, so let's try to look at it here. Okay, according to plant setup, you would have your integrated, your split type, according to the number of digesters, single and multi, and according to the gas chamber design, it's floating, fixed, or balloon. And now the student or the learner in the class at this moment is expected to be knowing or knowledgeable of biogas systems. Okay? In particular, the processes, because this is a biochemical process. The student or learner is expected to know of the uh, biochemical processes involved in biogas systems. In particular, okay, this uh, this stages of the digestion, okay, in the biogas digestion process, from hydrolysis, acidification, and methanization. And also, likewise, the parameters that are involved, such as the temperature, the acidity of the, the mixture that is being handled, uh, from the slurry, okay, to everything that is involved in the production process, and available nutrients, inventory factors, the nitrogen content, and the carbon nitrogen ratio. And also here, okay, in this discussion, focus will be on the structural components. Thus, okay, it is important that this biological processes, biochemical process, is already firmly understood by the student or learner. All right, so let's proceed to the components. It is important that, okay, that the student or learner is familiar with the parts of a biogas system or a biogas plant. And before we proceed to such, it is important again to take note of the considerations in terms of locating or siting the biogas plant. Should be located with at the site with good drainage. Should be located as near as possible to the source of the material, the animal pen, and should be lower than the elevation of the animal pen. Okay, to lessen the cost of moving materials from, okay, the waste materials from the animal pen to the chamber. And also, okay, since this is a production of this is an energy source. Okay, this is an energy source, so energy production should be also utilized. Now, the energy produced should be utilized nearby. And soil foundation should be stable and away from tree roots. It's most well, it's recommendatory only, but well, to avoid damage to the system, because the trees could still be growing, okay, and the root system could interfere with the system. Now the parts, you have a collection tank, a collecting tank, collection or collecting tank, and these two take note of the the quantity of manure that a certain animal produces. The again the system efficiencies are already been or would have already been discussed in in uh, agricultural power and machinery or in renewable energy systems. Those two courses are detailing the biochemical process of biogas production. Okay, so there are also the continuous type of continuous fed biogas plants, and then also your batch fed, okay, where the slurry is um, discharged or charged into the system in batches. Okay. Now the dimensions of the tank should accommodate the output of the uh, design or the existing source of waste. Modular types could be used instead of well redesigning the overall tank capacity. Okay, so uh, another important concept in biogas production is the retention time. So this should be considered, and how much is required for the different substrates or that come into uh, the tank. Okay. There is an optimal there are optimal dimensions for the system, and this is presented in table 3. The height and length ratios of the height length dimensions are provided. Okay, this is for circular, rectangular, and square cross sections. Again, the biogas digestion process should be contained with it, which means it should be without without the presence of oxygen, right? So it should be anaerobic. So the oxygen should be consumed and well removed from the system uh, to be able to produce the methanization or to for methanization to undergo. Okay. Other parts, so we have here the output pipe, okay, and the outlet tank volume. Another consideration is that there should be space for the gas to fit in the tank. Okay, for the fixed type and balloon types of digesters, there should be a 20% volume freed up, okay, to accommodate the gas. Again, at the top of the system or the tank or the digester, the gas will be uh, pressurized. Okay, that should also be uh, understood by the designer of the digester. You have also the inlet pipe, right? Here. So we have here the requirements for the design of the tanks, which involves the channels. See, there's a slope, minimum slope of 2% to facilitate gravity movement of the materials by gravity. Should be concreted. Okay, recommendatory only. Okay, this is also recommendatory. The mixing tank, okay, for inclination. Okay. Inlet pipes. Okay. Cover made of jelly sheet shall be provided that should cover the tank. You have your inlet pipe, and then the digester itself. Okay. The digester should be made. So it's recommendatory, but you have a lot of choices: cement, metal, adobe, bricks, reinforced concrete, or reinforced concrete hollow blocks. Okay. Uh, Please do take note of the different mandatory requirements. Steel reinforcement shall be used for larger digester volume. Concrete walls of the digester shall be reinforced with GI, chicken wire mesh, before plastering with Class A mortar mixed with sealing compound or waterproofing compound. So while there are recommendatory materials at the top, okay, the use of specific materials are have mandatory provisions as provided here at that succeeding guidelines, right, or standards. So floors, beams, and foundations shall withstand the maximum load and shall be made of reinforced concrete. The access to the digester should be through the manhole or through the outlet chamber. If a manhole is used as the access inside the digester, it should be constructed in the center of the dome. It should be tightly sealed. Okay, this is for the fixed and floating type. For the balloon type, okay, a trench should be dug out. That's recommendatory. The sides and floor of the trench should be another recommendatory. Smooth. Okay. The floor shall have a slope. That is a mandatory requirement. Okay. So the floor is 2.5%. Unlike here, it should be, I think it's not sure if it's 2.5 as well. Anyway, we have the balloon. Okay, should be made of red mud plastic, natural polyethylene plastic. So these are recommended materials for use. Now for the agitator or stirrer, okay, natural agitation is recommended for the smaller designs, but for bigger, okay, that should be facilitated with mechanical or with a rotary motion by mechanical means. So you have your well, this is to be in collaboration or practiced with knowledge of machine design, right? So in terms of structural components, so this is a fixed material that should be considered in the weight of the system or the dead load of the system, dead load influencing the system. For the gas chamber, you have your floating drum plant and should have a sloping, okay, recommendatory mostly here. Okay, the sidewall of the gas drum shall be as high as the wall above the support ledge. Guide frame shall be provided to prevent the floating drum to come in contact with the outer wall and to allow the gas drum to be removed for repair. So this is a a portion of the biogas digester or the biogas plant where, okay, the gas is collected. And there's also another fixed dome plant, and it's recommendatory or it's mandatory that it should be if it's concrete, then it should be reinforced with screen before plastering with Class A mortar. The gas chamber shall be capable of withstanding internal pressure of 0.15 bar. Again, this is a pressurized vessel. The top part of a fixed dome plant shall be painted with a gas tight layer or a waterproofer or latex or synthetic paints. A wick ring in the masonry of the digester should be, okay, this is recommendatory. And then for the gas outlet, this is now to direct the gas produced, okay, out of the system. Okay, piping system is connecting to the gas range or yeah, whatever. If it's going to be a reservoir to contain the gas, it should be also designed properly. Okay. Gas outlet pipe shall be provided, and it shall be connected to outgoing biogas valve. All valves or cock valves should be used. Okay. It should also be installed at all gas appliances as shut-off devices. So these are more recommendatory as to the materials to be used, GI pipes or PVC pipes. But here are the standards for the dimensions of the materials to be used depending on the quantity, okay, in terms of the flow rate in meters cubed per hour. Okay, recommendatory into the in the piping system as well. But here, if depressions in the piping system cannot be avoided, water traps shall be installed at the lowest point of depressions with a minimum inclination of 1%. Flame arrestor shall be provided. Again, the system deals with a combustible material, thus fires or flames should be expected if ever a leak happens to be in the system. Outlet pipe, right? More of recommendatory if it's concrete for the fixed type, okay? For the balloon type, and then for the floating type. But it is to be required that the outlet pipe is sealed. Okay? For the outlet tank chamber, this is now to receive the um, the used up slurry, okay, or the sludge, okay, and this, okay, are recommendatory, but the chamber shall be provided with a cover made of ordinary or corrugated GI sheets. With the gas fully developed in a biogas digester, so the sludge would most probably be smelling less than when the slurry just entered the collecting tank. Okay. For groundwater drainage, okay, please do take note that there's a need for a freeboard, 15% freeboard, and this is to be designed as similar to dams in land and water conservation. Okay, groundwater drainage. If the water seeps from bottom of the excavated pit, blind drain should be constructed, and okay, it should be filled with gravels or chip of tiles, okay, whichever. If water seeps from wall of the excavated earth bank, circular drain outside the location of the digester wall shall be constructed to lead away the water to the sump or some lower places. In case groundwater is in great quantity, deep wells should be constructed. Okay. Facilities, heating systems, okay, to heat up the slurry or the substrate if ever needed. Okay, another recommendatory portions, pumps. Okay, this is another requirement if ever to move the slurry or the other outputs of the system. Safety considerations, visual check, okay, water holding mark. These are mostly recommendatory in degree. Okay. Then the sludge management is also like this here, but more of recommendatory still in provisions. All right, so that's all for the biogas. Okay, these are presented by Annex D. These are the sample designs of biogas systems, and we have here also some computations and the formulae for used for the design or for the biochemical reactions in the system. Okay, so next off we have the waste management structures for wastewater. So this is to be following in particular the administrative orders of the Department of Environment and Natural Resources. The wastewater and waste management systems are discussed in detail in the course waste management. This is, I think, a course after this in the curriculum of agricultural and biosystems engineering. This is a course after this topic on structures. All right, so the student will have to do some advanced reading to understand these concepts of dissolved solids, okay, effluent, What are these? Facultative lagoons, fixed solids. Okay. So in particular, the discussion in this topic still will be on the structural components. And it's important to take note of the parts of the system of wastewater management, which are the alleys, the gutters, okay, the runoff collection system, okay, the reception pit, screens or screening, and then you have also shredders or comminutors, which are to be discussed in detail or in conjunction with machine design, because those are involving mechanical processes. Although these systems can be fabricated as dictated by machine design, there are available or commercially available uh, equipment and parts to fit such operations. There's also the sedimentation tank, oil increase interceptors, interceptors, and then also storage gutters. And for those that are, well, with open types, you have your lagoons, and there's also a concentration of aeration, which is a portion that is in aquaculture engineering and should be discussed or should be uh, taken into consideration as the student goes through that the topic on aeration. So please do take note of the typical process diagrams here. You have your liquid waste, then you have primary treatment ponds, secondary treatment ponds, and then you have your treated liquid waste. This is for natural treatment and ponds. Now, treatment is happening via biochemical processes. So bacteria could be introduced into the system or chemicals to react with the wastewater. In poultry dressing plants, you have the blood, okay, and the wastewater from cleaning of the carcasses as the wastes of the system of poultry dressing. And then you have your liquid waste here. This is for without primary sedimentation, but there's aeration and the process of setting to collect the sludge, okay, and to separate the liquid from solids and to dispose of the solid separately. And then you have your conventional liquid waste treatment plant, where there are screeners, okay, to remove the solids, the grits, and, well, the sludge in general. And again, to separate the solid waste from the liquid waste, the treated one in particular. So location is important, and here is to take note of the need for soil analysis to determine if, well, what is the clay content. Okay, it shall be 15%, and if constructed another soil type, sealant shall be provided to avoid leaks or leakage into the groundwater, because that would mean contamination of the drinking water, if ever, because well, the groundwater is maybe an expanse that the people have no idea with. Okay, what if it's a confined aquifer? So contamination would spread, or yeah, it would spread throughout that aquifer and be contagious, if ever, to people with access to that aquifer. Liquid waste facility should be, so this is recommendatory, but this is to avoid complaints from residential areas where the air could be directed from the wastewater treatment facility. Functional requirements, again, the alleys, okay, these are mandatory, shall be 2.5 meters to 4 meters wide, okay. And there's another type, the flash alley. Please take note of this um, requirements or mandatory requirements. Again, the idea is to collect the wastes, the waste from, or to move the waste from the facility. And you have here for dairy and swine, okay? And then the gutters to direct this towards the 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 ponds or uh, the facility itself. Okay, you have your step dam gutters, your scrape gutters, your flush gutters, and then water that comes from other sources, rain or rivers, should be diverted away from the system. Okay, but this is more of recommendatory than mandatory. So reception pits, okay, slurry and liquid waste collected should be collected. More of recommendatory still. There's screening, and you have two types: your coarse and fine screening. Different types of screening devices are herein presented, and the type of materials, and more of mandatory still in category or degree. And then there's the size reduction. Again, the comminutors and the shredders to be developed in conjunction with machine design considerations. Solid liquid separation, grid chambers, okay. And then the sedimentation tanks, more of still recommendatory in degree. Okay. But here, please do take note in table 7 the dimensions, okay, in terms of depth, length, and width. Settling channel, screening, evaporation, okay, and the storage, gutters. And the storage pond, okay. Lagoons are to be designed similar to dam design and management in aquaculture and also in land and conservation, land and water conservation courses. The sludge volume, there's a formula. This is to determine the output depending on the animals, and the sludge accumulation ratio differentiates the animal. Okay, so a freeboard is to be accounted for. Again, similar to the dam design. Aerobic lagoons is designed differently with anaerobic lagoons. Again, difference in the aerobic with anaerobic is the presence of oxygen. So in aerobic lagoons, the biological oxygen demand is identified. Okay, and this is a mandatory requirement to compute for the TSA, treatment surface area, because the water surface should be in contact with air or oxygen in the ambient air, right? So also mandatory requirements are the freeboard, okay, the depth of the lagoon and maximum level. And for mechanically aerated lagoons, okay, this is to improve the biological oxygen demand, or the biological oxygen dissolved biological oxygen, dissolved oxygen in the DO inside the lagoon. Thus, this should be computed as required based on aeration principles or computations. The sizing of the aerators have to be computed, but this is it's beyond the concept of course. So please take note of the structural components such as the embankment and others that have been discussed, and then inlet and outlet or the pipes, okay, dimensional requirements or mandatory requirements or recommendatory ones, the overflow water supply, okay, the mixing, and then the detention time of the of the of the wastewater. Okay, so most of this are recommendatory in provisions. So a holding pond could also be constructed, and then effluent treatment for filtration. Okay, sludge treatment, and then odor control. Okay. Okay, so there's also inputs into safety, because again, gases could create fire. Okay, so and also the gases are obnoxious because there are reactions inside the system, and could be um, uh, could be hazardous to the operators or the people handling the system. Okay, so here are the typical uh, components of the processes of wastewater treatment, okay, and the waste characteristics of the different animals and fruit and vegetables or crops that are being handled. All right. Next would be on agricultural solid waste or composting. Similar to the previous standard, this should be well, the processes here should be in detail or studied in detail with reference to the processes to be discussed in waste management, okay? Because this will again be tackling different um, concepts such as the CN ratio, the carbon nitrogen ratio, okay, the leachates that the system is producing, curing, okay. But in here, the discussion will be focusing on the structural side. So location still conforming to the DNR administrative order and the environmental code on solid integrated with waste disposal. So systems that produce solid waste, such as those in farms, uh, should be considering or should be are mandated to follow this standard. So uh, the types of waste disposal systems, storage or composting, a windrow composting, aerated static pile, and in-vessel system. This simply differ in the construction of the system. Please do take note of the design. So here are the windrow system. Should be 1 to 2 meters high, 2 to 5 meters wide. And here is the static pile. So there is a pipe system that directs the flow to reduce the odor of the system as the pile uh, is retained inside the composting system. And here is also another duct placement system for the static pile. Okay, for in vessel, okay, they should be also designed. Okay, here is a wait, this for the in vessel. Let me just see where. Because for in vessel, there should be a construction of an enclosed system to contain everything that is in the in or the waste in the produced by a building where there is waste production. Okay, the pile shall be cured when turning no longer results in an increase in temperature. The pile should not be stirred for 1 to 2 months. After curing, the compost should be screened if necessary to remove any non-biodegradable components and should be analyzed to determine nutrient value. Okay, because this is deemed organic, okay, it shall conform the compost output of the composting pit or the composting system shall conform with the standards of the organic fertilizers set by the Department of Agriculture. Okay, so most of these are biochemical reactions again, and they are to be designed with knowledge of the structural components, or as the structural components are required by the biochemical processes. Next is warehouse for grain storage. And again, grains could be any type of uh, produced from crops that are carbohydrate in base. Okay? So grains such as barley, rye, wheat, rice, okay, and others. Hops, is it grain? Anyway, I tried to I'll try to check that. Okay. Right. This is again a standard for a warehouse. And please take note modular the modular design of this warehouse, which means this portion could be taken as one unit, and then the other a unit that is similar to that first unit. That is the modular design. And important here still in terms of the structural components, the location shall be accessible to all forms of transport systems. The warehouse is a temporary storage facility to address food issues or concerns, or to stock up, and when there is for times where there is low production. So these are required. Sites shall be dry and located at areas that are free from flooding, shall be free from fire hazard. Okay. Long access of the warehouse should be oriented east-west. This is recommendatory because again of the radiation of the heat of the sun. Structure shall be built on a stable ground soil. Space shall be provided for future expansion. Electricity, communication, and water services and drainage should all be available and reasonably economical. For functional requirements, you have your again the design should meet the demands of the products. So if it's kind of grain, what kind of grain is that? That those should be considered. And the dimensions of the pallets are one of the key important aspects that a designer of a warehouse should consider, because the spacing of the floor is to be designed such that these pallets are or would provide ample space for the movement of people and equipment, such as moving ones or mobile ones, such as the forklift. So for small scale storage, here is a recommendatory packing. Okay, and then for large scale storage, you have your block stacking, your Chinese method, okay, and also your Japanese piling method. Criss-cross stacking also provided, and should be considered in the design of the structure. Okay, so recommended stack heights for different grains. Again, sorry for I was just joking. Hops is actually flour, and because I like beer a lot, she would, when you're talking about beer, which is best at anyway, -4 degrees Celsius. Anyway, we have to be back here in the discussion. Okay. So pathways, that's a requirement, but okay, still just recommendatory. Should be 2 meters wide, okay, but not less than 1 meter wide. For forklift requirements, there's a recommendatory space still, then solid spacing between the wall and uh, uh, the piles, and then for the physical dimensions, okay, here is a table that identifies the dimensions required depending on the number of bags to be contained inside the structure or the building. Sorry, height of structure, okay, between the eaves line and the floor is 7 meters, and 2.5 between the eaves line and the apex of the structure of the building. There shall be provisions for water tightness, shall be provisions for efficient loading and unloading bays. There shall be provisions for aeration, shall be provisions for bird and rodent proofing, and for fumigation. Fumigation is the process of disinfecting the location. A building shall have a clear inside span and has no inside pillars which could obstruct stacking arrangement. The building should have a ledge or podium. Illuminations, the skylights can be used instead of the regular GI sheets. Electrical works to be designed along with the electrification course. A drainage shall be provided. Okay. Structural requirements, foundation, floors, walls, they are all mandatory in the requirements. So to withstand, floor should withstand heavy loads and vibrations, shall be elevated, floor shall be elevated. Okay. There shall be provisions for wear resistance and safety, particularly in skidding. Walls, internal surfaces of the wall shall be smooth. Okay. Shall be painted white, shall be no opening between wall and roof. This is for to prevent it or to in climate control areas, if ever, in those kinds of warehouses. The the idea is to maintain the moisture content of the, again, grains are biological materials, so they are hygroscopic in nature, meaning they could they regulate or they equilibrate with the the ambient air conditions. Thus, the product will be reacting as required, and thus, okay, in some cases, warehouses are controlled or controlled environments. Okay. Roofing, okay, shall be roof frames. Okay, internal pillars supporting roof frame shall be avoided as it interferes with pest control and other stock management. Okay, a standard roof truss of 14.5 meters span should be used. Roof frames made of wood or steel shall be designed so that they transfer the weight of the roof to the supporting columns or to the walls. It must be provided with necessary lateral and vertical wind brace to resist forces due to strong winds and earthquakes. Okay, the next is mandatory. The roofing materials made of galvanized iron sheets and shall be in light colors, white or beige. The external surface should be reflective of light or light colored to minimize the amount of heat that it can absorb. Okay. Chosen materials may be fireproof and with what they mean with refractory, and with refractory properties. Okay. Doors shall be at least in twos, or so as to be able to rotate stocks on a first out basis or FIFO basis. Okay. Doors shall be wide access, made of steel, reinforced along their lower edges with metal tape. The size of the entrance is 6 meters wide and 4 meters high for normal temperature warehouse. Okay. Canopy shall be constructed. Ventilation, another important thing that should be discussed in environmental control, but should be left out here. Okay. Rodent proofing, more of management already. Okay. All right, so this is a sample floor plan. Let's proceed now to the farm workshop. Okay. The farm workshop is particularly the uh, the place where the materials or equipment used in production operations are stored. Okay. So This is a support to production operations, and the downtimes could lead to overhead costs. Thus, still, okay, the workshop and the machinery shed are to be designed according to standards. It is important that the equipment are maintained in good running condition, okay, because machines devalue from 2 to 5% if without um, protection. Okay. Also, this this um, this is this structure or building, okay, are are also important to protect the equipment from theft and vandalism. But in this discussion, okay, this will also cover uh, fuel and chemical storage, which are also support operations in the farm. Okay, so the space requirement is as provided. Okay. You have the space in a machine bay area and the service area, okay, and the access door. Okay, it's important to protect the equipment from wind, rain, and other elements. Okay, the floor should be dry, firm, and preferably concrete. So should be concrete. But if not, then should be shall be gravel packed. So that's the minimum gravel packed. Walls shall be enclosed with solid walls or wire netting. Roof span, if it's less than 3 meters, then only a beam shall be used, but truss if greater than 3 meters. Roofing material shall be made of GI sheets. Okay. Shall be floor height from floor to truss shall be at least 3 meters. For machines higher than 3 meters, the height shall be the sum of the machine height plus 0.3 meters or 30 centimeters, 300 centimeters, 30 centimeters, sorry. So one ruler. Door gate requirements, okay. The height for overhead. Okay, so this is just a preference against hinge doors. So overhead or rolling doors are more preferred. So there shall be provision for smaller service door so that it can accommodate human beings. Okay, if ever people have to come in, go in and out of the building. Then functional requirements, okay, gravel pack, apron as an approach to the shop. Okay. Going into the shop should be gravel pack to avoid dirt coming into the facility. Okay, there should be there shall be an A-beam or a hoist for removing of components such as the engine, okay, of a tractor. Workbench shall be at least 1 meter high. Okay. A welding area, fan. Okay. There's actually computation for the movement of air. Here, it is recommended to be, or it is required to be 28 to 57 meters cube per minute. Okay. Okay, if vehicles are to be operated in the shop for a period of time, an exhaust hose through the wall or a small suction fan pulling exhaust through a tube from the exhaust pipe shall be provided. Okay, this is to avoid poisoning. Okay, carbon monoxide poisoning to the operator, to the mechanic. Okay, for fuel and chemical storage, a concrete storage room shall be provided for the hazardous materials inside the workshop. Okay, the floor shall be concreted to form a reservoir to contain any accident spills, avoid water contamination in the soil. Okay, ventilations shall be constructed. Okay, storage room shall be vermin-proof. Electricity and lighting shall be conforming with the standards of the PEC. And here are the lighting levels required. For the bench, requires the most because it it uses more or it details, it involves details more. Drainage and plumbing and also safety are also likewise mandatory. Okay, so here is a sample work, a floor plan for the system, and the part or the combinations of machinery and equipment, machineries and equipment inside the facility. Okay. All right, so next and last would be the silo. Here, the design of the silos actually could be vertical, could be horizontal, could be also floating. Okay. But again, the purpose of a silo is to contain feedstuff or grains. Okay, so there should be, because this is very big usually, there is a need for the concept of mechanics or mechanisms such as the loading system, okay, which would involve conveyors and then hoppers, okay, to facilitate the distribution of the grains or the feedstuff inside the silo. Okay, so the parts, okay, this should be considering or should be um, following the standards set herein, right? So the different parts, okay, are also provided here. Location, okay, let's focus more on the structural components. Site should be dry and the structure shall be elevated to avoid water logging. The structure, as far as possible, should be well away, shall be free from fire hazards, shall be built on stable solid ground. Okay, access is provided via road and also other utilities. Seismic conditions shall be given consideration such that the structure will lie on fault lines. Structure shall have means to prevent entry of birds, rodents, and other pests. The silo shall be able to withstand the maximum wind speed observed in the area. Okay. And these are the structural components that are required: foundation, okay, flooring, base flooring, silo flooring, the walls, okay, the roof, and then the safety requirements. Because again, we have moving equipment or moving parts here from the conveyors, the belt, the screw, the chain, the pneumatic, and the bucket elevator types. This would have components that are moving continuously during operation of a silo or the filling up of a silo, and likewise during in unloading it. So there's the hopper underneath. All right. So also this could be automated, and there's a provision for control systems via electronics. And so this should be designed in conjunction with both mechanical and machine design and electrification. And also likewise the monitoring of the grains, which is based on material requirements. Okay. So those are the parts of the structural components that have to be required and shall be conforming to these standards. So that's the word, conforming. Sorry, a while ago. All right, so that's all for this session. The next topic will be on materials in service conditions, and also the different defects or defects and possible remedies to encounter those defects in materials that are in service conditions already. I'll see you next time, and thank you for listening.